This is section 001.005.007. Each element has its own number of protons and a number of neutrons. So far, we were talking about hydrogen, and we said hydrogen has 1 proton and 1 electron, and it has a nice orderly of orbitals, and the orbitals are the energy levels where the electrons are when they are in the right motion to be attracted to a positive nucleus but not smash into it. So they're limited in their space, they stay with the nucleus, but they don't crash into it because they have some motion. So that's all fine and dandy for hydrogen. Then we said, well, what if we take a hydrogen, we could give it an extra electron, so we could have 1 proton and 2 electrons, and then we saw that the electron cloud splits out into all those energy levels we just looked at. The other thing we need to talk about is how we get more elements. And so this is kind of a cool thing too, if you were going to figure out how to make different things. If you have 1 proton is hydrogen, element number 1. If you have 2 protons, it's element number 2, and boom, it's helium. Hydrogen has a whole series of chemical properties and physical properties. Helium has 2 protons, and boom, it has totally different chemical and physical properties. The other thing we want to talk about is that if we have helium, we've got 2 protons, so we've got proton 1, and we've got proton another 1. And think about this, 2 pluses in the same place. They shouldn't want to be together, because plus to plus should repel, right? Plus to minus attracts. Plus to plus should repel. And so energy has come up, nature has come up with the system. We can put in here a neutron, and in the helium nucleus, there are 2 protons and there are 2 neutrons. And so even though helium is element number 2, you may have noticed that it weighs 4. And the reason it weighs 4 is because we have to have some neutrons in there to help interact, to help make a stable interaction between the pluses of the first proton and the second proton. So that's just a little mention about why the neutrons are thought to be there. They help to hold the nucleus together because a positive charge to another positive charge should be repulsive, and that means that the nucleus would fall apart. The other thing we want to say is that as we come across them, the first element has 1 proton, the second element has 2, the third element has 3 protons, beryllium has 4 protons, boron has 5 protons, carbon has 6 protons, nitrogen has 7 protons, oxygen has 8 protons, nitrogen has 9 protons, and neon has 10 protons. As we increase the number of protons, we increase the amount of positive charge we're trying to put in one place, and so the neutrons keep up, and as you come across this is the atomic number of each of these elements, and the atomic masses are larger than that. Lithium's atomic mass is almost 7, because to hold 3 protons together you need 4 neutrons. Oxygen, we know its atomic mass is usually 16, so for every 8 protons we hold together, there's approximately 8 neutrons on it. Well, there's exactly 8 neutrons in most of the oxygen, and then there's other numbers in some of the oxygen. And so each of these, as the amount of protons increases, the amount of neutrons increases, and that makes the atomic weights of each of these substances. But at this point, what we're concerned with is we're making new nuclei. So this is 001.005.008. The energy of the electron clouds in each element changes with the number of protons. So our next idea is that if we have the protons down here, right, we've got a nucleus, and then around the protons we've got our electron clouds, and these are big moving electron clouds, and the electron is not in any one position, but it could be in a spherical orbital, And really, it could be anywhere. It goes in and out and through, but if we took a time average of where the electron would be, it kind of tends to be on this sphere. And actually, it can zoom right through the nucleus, so that even that can happen. Then, in the second quantum level, we would have another set, and this is bigger, but it's also moving everywhere. And then we knew we could have, in the second quantum level, we could have 2 electrons of one kind and then 6 more, and those are thought to be moving sort of this way. And there's a couple different ways to draw that picture, but it has different orientations of it. So an easy way to think of it would be from top to bottom, side to side, and front to back. That would give you 2 this way, 2 this way, 2 that way. That would be 6 more electrons. Then in the third level, this is even bigger. And this is just our outer limits, but the electron is everywhere. And then we also have the front to back and the side to side and the back and forward ones, and so those are in there. So now we've got 18 electrons in this picture. Then we go to the fourth quantum level, it's even bigger. And this is everywhere, right? The 2 electrons in the spherical orbital could be everywhere, really everywhere in that limited energy. And then we've got the top to bottom one, and we got the side to side one, and we got the front to back one. And then we've got ones that are off axis and ones that are between axis. And so in the fourth quantum level, we have, well, they're all big in the fourth quantum level, but we have some that are spherical, some that are in 3 dimensions, some that are sort of in, they're 5-fold, and then some that are 7-fold. So this is a picture of the atom, and in the center here, we've got our nucleus with positive charge. And out here, we've got all these electrons with negative charge that are in motion, and they have momentum that keeps them from smashing into the nucleus. Well, from one atom to the next, right? This picture, this is nothing new. I've already told you this. But our next step is that we come in here, and instead of having 1 plus for hydrogen, right? Well, now, first of all, for hydrogen, hydrogen has all these levels. They're just not occupied. But you take that hydrogen atom and you zap it, and you can probe that all those levels are there. Well, if we come in here, instead of having 1 plus, we have 2 plus. Everything is like this, except that the interaction of 2 pluses changes the force field. So this whole rank of energies shifts. It just kind of oozes. Because when there's 1 plus in there, it has one pattern, and when there's 2 plus, it's all just like it was for 1 plus, except it's a little bit different, because 2 pluses does not make the same force field as 1 plus would make. Then you come to lithium, you've got 3 pluses in here, and all of the underlying structure is the same, but the relative positions of all of these, how far they are, and how much angular momentum you need, and how much motion there is to keep the electrons from smashing into the 3 pluses is even greater. So, but that's not a very nice picture. So what do we do instead is we make energy level diagrams.